All right, so at the end of the day yesterday, we were looking at 3C, where we had an 8-meter east vector represented by that red line there, okay, followed by a 6-meter vector 35 degrees north of east, okay, and we're looking for the total. So, much like the ones we were doing yesterday that were exam level questions, so is this, okay, we got to find all of our x's and y's next, okay, well, red x, that is how far horizontally that first 8-meter east vector goes, is simply 8 meters east, right? That's all that vector does. It has no north or south part to it. It doesn't travel north or south. So the y component of a horizontal line is 0. Okay? When we're looking at the green triangle, okay, we've got to do a little calculating for that one. We've got to find x and y. Okay? So we do our trigonometry. We recognize that x, green x, is adjacent to the 35-degree angle. Okay? So we go cos of 35 times 6 meters. Got to fire up my calculator. Okay, and then for y, okay, it's going to be the opposite side, so we would have the sine of 35 times 6 meters, okay, to get those two sides. Okay, so cos of 35 times 6. Okay, so we're looking at 4.915 or 4.91. Okay, so 4.91 meters east. Okay, and for our y component, okay, we'll do sine for that one. Okay, so the sine of 35 times 6 gives us 3.44 meters north. Okay, so now that I've calculated all the x's and all the y's, the next step is to build the triangle for what we call the resultant. In this case, the resultant represents the displacement of the object. The resultant can represent lots of things. Okay? In this case, it's displacement because all the vectors are displacement. If all the vectors were velocity vectors, then it would be the average velocity. If they were all force vectors, then it would be the net force. Okay? It's just always the vector sum of whatever it is you're adding. Okay, so this represents our total displacement. I need to find its x and y components. Now, the only time in this whole trip where this thing goes north or south is in the green triangle. Agreed? All right, so what's the relationship between green y and blue y? They're the same. Okay, it's the only time this object goes north. So really what I'm doing is going 3.44 meters north plus 0, because in the first vector we didn't do anything that way. Okay, so I know that blue y is 3.44 meters, and it's north. Okay, now, blue x is going to be 8 plus green x, right? Blue x has got to be equal to this side of the rectangle. It is a rectangle, after all, okay, that I've built there. So those two sides have to be equal, so it's simply going to be 8 plus 4.91. Okay, so that'll be 12.91 meters east. Okay, everyone following what I did there? Okay, so have we done the same steps every time? Tick tock, Brody. Okay, so we've done the same thing every time. First we draw the diagram, then we label the x's and y's, then we calculate the x's and y's, then we find our final triangles x and y, okay, and then we do Pythagorean theorem, and then we do trigonometry, and then we're done the question, right? So what do we have left? Pythagorean theorem and trigonometry, right? That's it. That's what's left in this thing, okay? So I've got the two sides of the big triangle, so Pythagorean theorem will get me the magnitude of d there, so that'll be the square root of the 3.44 squared plus 12.91 squared. Okay, so squared plus that number squared. Okay, so we're looking at a total displacement there of 13.37 meters. and then we need a direction. Now I drew the triangle this way today, but yesterday, at the end of class, I drew it here. Does it make any difference? Not really. I'm just going to get the complementary angle. I'm actually going to get the one that's in the answer on this one. Okay, I'm going to get the 75 degrees east of north. Is it okay if I get 15 degrees north of east? 100% okay. It's the same direction, just the reference is different. Okay, so when I do this, the next thing I got to do is find that angle. Okay, looking for theta here. Right, so tan to the -1 of the opposite side, 12.91. Okay, divided by 3.44. All right, when I do that, I'll get 75 degrees east of north. Okay, my final answer, how many significant digits? Every number I have in that question has 2, agreed? The 35 has 2, the 6 has 2, the 8 has 2. Okay, so my final answer would be 13 meters, okay, at 75 degrees east of north. Okay, like I said, guys, the only way to get better at this is to practice. Since this is what's on your quiz tomorrow, I've kind of set this day aside to practice this stuff, and if you are having trouble or you have questions, today's the day to ask. Let me come around and help you out. If it's with the drawing, no problem. We can work on the drawing. If it's figuring out east and north of east, that's fine. We can figure that out. There are no bad questions. Okay? Every part of this can trip somebody up. Okay? People get tripped up on different things. Okay? You can't look at something and go, I feel silly for asking a question about this part. No one else is getting tripped up on this part. I guarantee you somebody else is getting tripped up on that part too. Okay? It is okay to ask for help today. This is a huge concept. Everything we do builds on it, so we have to know how to do it. All right? Okay, I want you guys to try F right now. Okay, so this is in the workbook. If you're having trouble reading it up here, it's also in the workbook. It's the vector addition sheet. Okay, so do F there, guys. Do you want me to leave the solution up or erase it? Which one would be easier for you? Like all this crap that has to do with C. Erase it, then you can take it off. All right, working on F then. Okay guys, that's what the diagram for F should look like. You got a 9-meter long vector going 35 degrees north of east, okay? And then you have a 7-meter long vector that is moving at 25 degrees south of east, okay? So you should end up with something like that where you are going to end up slightly northeast of where you started. All right. Here. So we've done the first step, okay? We've drawn the diagram. We've done the second step. We've identified all the X and Y components. All right, so we're going to start chronologically. The 9-meter vector happened first in the question, so we'll start with it. Okay, so we have a 9-meter vector, 35 degrees north of east. So to find the X component, that's adjacent. Okay, so I'm going to go X equals, put in blue. Okay, X equals cos of 35 times 9.0 meters. Okay, so we're looking at 7.37 meters east. Okay, y is the opposite side, so we'll go sine of 35 times 9.0 meters. Okay, so we got 5.16 meters, and that one is north. Okay, so we have an easterly directed vector, and we have a northerly directed vector out of that triangle. Okay, for the red triangle, okay, we're going south and east. So to calculate x in that triangle, x is adjacent, so we'll go cos of 25 times 7 meters. Okay, so 6.34 meters, and that is east. Okay, and then for y, it is the opposite side, so we'll go sine of 25 times 7. Okay, so we got 2.96 meters south. Okay, so now I found all the x's and all the y's. What do I do with them? I combine this, okay? So I look in the first one, x was east, and the second one's x was east, so I can just add them, they're both in the same direction. Okay, so green x is very simply going to be the sum of 7.37 meters east plus 6.34 meters east. Okay, and so that's going to give us, so we'll take those actual numbers, the 6.34, and we'll add it to the 7.37. And we get that this thing traveled 13.72 meters east. Okay, now the y's, one goes north, one goes south. So what do I have to do when I combine them? Yeah, subtract or add one, making the south negative, okay, whichever, okay, so that they actually subtract or make it smaller, right? So we'll take our our 5.16, that's the north, and we'll subtract the 2.96, which was the south, and we'll get that y is 2.20 meters north. Okay, now I've combined the x's and y's. What's my next step?
Displacement?
Yeah, find the total displacement using use Pythagorean theorem. I've got the two sides of the green triangle. Okay, there's nothing saying I can't get, okay, the displacement, that big green solid line, right? So the total displacement will be Pythagorean theorem of 13.72, that's the x squared, plus 2.20, that's the y squared. All right, so punch those into our calculator. That one squared plus that one squared is going to give me 13.89 meters. All right, that's the magnitude of the displacement. I still need the direction. Okay, I have all the sides of the triangle, so I can use any trig function I want to find theta. Okay, for me, I'll use tan. So tan to the minus 1 of 2.2, that's my opposite side, divided by 13.72. Okay, that would be the adjacent side, right? And I'm going to get 81, actually I'll get 9 degrees. I'll punch it in so we actually get the decimal here. Second tan of 2.2, okay, I'll use the numbers. Okay, 2.2 divided by 13.71. All right, so I'm getting 9.13 degrees. Okay, and for me, that is going to be measured from due east going north, so north of east. So either one of these answers is going to have how many significant digits? 2. Every number I was given had 2 significant digits. So if I write it this way, okay, where I'm referring east of north, which just means I drew the triangle this way instead, okay, that's totally fine. Then I get this giant angle, which is 81 degrees east of north. The way I drew it, I got the little slim angle right here, which is going to be 9.1 degrees north of east. Okay, makes it seem like it's more accurate, right? Because it's got a decimal place, the other one doesn't, but they both have 2 significant digits. Thus, I'm reflecting the accuracy of the numbers I used. Okay, questions on that one? All right, before we go into other vector ones like this, I want to introduce something a little bit new. Okay, and these are what we call boat questions, okay? Because they usually involve a boat, okay? Or a plane, which is a skyboat, okay? So, in a boat question, what you have is perpendicular vectors, okay? So, if I go down to the sheet down here, okay, and I put a canoe in, and I aim straight across the river and start rowing, where do I end up? downstream a little ways, right? Because what's going to take me downstream? Yeah, the current's going to take me downstream, right? I can aim at a point across the river all I want, but if I row at it, I'm going to go this way while I'm rowing. Everyone follow me there? Okay? If I want to end up at that point straight across the river, where do I aim? I aim upstream a little bit, right? I have to angle my boat into the current so the current will bring me back to straight across. Those are the two types of boat questions we would deal with. Okay? One would be rowing across, which oddly enough ends up downstream, and going across, which means aiming upstream and actually ending up straight across from your starting point. Rowing across, going across are the two types of boat questions. Okay? So what I want you guys to do is write down this first example of a boat question. Okay? Write this one down, and we're going to walk through how we do a boat question here together. Okay, so I draw my imaginary, terribly drawn river here, okay, and I simply indicate that this river is 200 meters across. I'll probably need that number later. They gave it to me, so I'm writing it down kind of as part of my givens here. Okay? The other thing they give me is that this person is like an Olympic rower. 3.5 meters per second is fast to row, especially if you're not going downstream with the current. Okay, so I'm just going to draw that vector, okay, as the rowing speed, and it's going directly north across the river at 3.5 meters per second. Okay, the river current is 1.2 meters per second east. All right, so I was given a second velocity vector. Where should I draw it?
In the end of the river?
On the end of which one? Here?
Yeah.
Yes. Okay. I should put it tail to head, just like I would any other vector. Okay. So if I draw, okay, that river current going due east at 1.2 meters per second, okay, is the line I draw from beginning to end pretty much what the boat's going to do? I think it is, right? If I row straight across and the current is pushing me downstream while I'm rowing across, that's what my boat's going to do. Okay? Like if I had a drone flying over top of me while I'm rowing the boat across the river, the drone would see me moving diagonally across the river even though my boat was pointed straight across. Agreed? Okay? It's no different than like on a windy day, okay, if you're trying, driving along the highway and the wind's blowing directly across, you have to like steer your car into the wind a little bit to stay straight. Okay? In this case, we're just letting the river push us downstream. We're not trying to correct for it. Okay? So this green line is what we would actually do. Okay? So the first thing the question wants to know is, what's the resultant velocity? Well, the resultant is always that line that represents the combination of the other two vectors. So that line would be the resultant velocity. Can I calculate that number? I can, right? I've got the two sides of that triangle. I can just do Pythagorean theorem at this point, right? That will get me the magnitude. That'll tell me how fast. But velocity is also what kind of quantity?
Just direction.
It also has direction. It's also a vector quantity. Okay? But I've got a triangle. Could I also figure out what direction that velocity is directed? Okay? These are just perpendicular vectors, right? Okay? So I can calculate the overall velocity's magnitude. I just go 3.5 squared plus 1.2 squared. Okay, so 3.7. Okay, so this is 3.7 meters per second. And then theta, okay, is just going to be like any other question, tan to the minus 1 of the opposite side over the adjacent side. All right, so that's going to be 18.92 degrees. And for me, that's going to be east of north. Okay, pretty sure I've got 2 significant digits there. So that's going to be okay. Everybody okay with that part? Right. We did perpendicular vectors like the second day. Okay? They just put them tail to head, do Pythagoras, do trig, and you're done. Here's the part where the boat questions are a little bit different. Okay, and it's not a vector thing, it's just they kind of have this other step. The second part of that question wants to know how far downstream they will be when they reach the other side. So that's a distance, right? Or a displacement. How many meters downstream? Okay, so what do I know here? I just did all this vector work, okay? But I know how wide the river is. Agreed? Okay. Do I know how fast I'm going across the river? How fast am I going across the river? Okay, that's our gut reaction, right? Because we just did all this work to calculate that 3.7. Is that 3.7 across the river? It's 19 degrees downstream of across the river. Okay? Do I have a speed or a velocity that is directed across the river? 3.5. Here's the thing we need to know about boat questions that's different. When we do a displacement question, it's this one happened first and then this one happened second. In a boat question, these two vectors are happening simultaneously. Okay? It doesn't change fundamentally how we do this. We still treat it like one happens and then the other. But what we have to recognize when we get to this part is, while I'm doing this, I am moving both across and downstream. And I know how fast I'm moving across and downstream. And I know what that combines to. The weird thing is that we're always asked what the combination is, but you never use it for anything. You only have to calculate it for its own sake. After that, it's useless. Okay? If I want to calculate how long it takes me to get across the river, I have to use vectors that are across the river. Okay? I can't use a north vector with a 19 degrees east of north vector. They don't go the same way. I have to use vectors that point the same direction. So I know I'm going to go 200 meters at 3.5 meters per second. Are you following me there? So I have D and I have
T.
Not yet, but I'll get it. I have D and I have V, right? So I can find T. I can figure out how long it takes to go across the river. Let me ask you this. Is how long it takes me to cross the river also how long I'm going down the river? It is. We just said those two things are happening simultaneously. If they're happening simultaneously, they also happen for the same amount of time. Because once I get to the other side, I'm no longer going to do either one of them. I'm going to smash the boat right into the bank and stop. Okay? So I'm going to go across and downstream for the same amount of time. The trip stops when I get to the other side. Okay? So, they want to know how far downstream we go. In order to know that, I've got to know how long I'm going downstream for. So I actually have to use the other information to get that. So these questions are very convoluted, okay? But they involve a little bit of vector stuff, and they involve a little bit of v equals d over t. Okay? All right, so if I want to find out how long it takes to go across the river, I'm going to do this. T equals d over v. Okay? I'm going to take that 200 meters, and I'm going to divide it by how fast I'm going in that direction. 3.5 meters per second, not 3.7. Okay, so if I do that calculation, that is how many seconds it will take me to cross the river. Okay, 57 seconds. Okay, for 57 seconds, I am moving both across the river and down the river. Okay, so if I know that I'm moving down the river at 1.2 meters per second, and I'm doing that for 57 seconds, can I figure out how far down the river I end up? It's just another v equals d over t calculation. Okay, so now I go d equals v times t. I take that 1.2 and I multiply it by the time I just calculated, 57 seconds. Okay, so I end up 69 meters downstream by the time I get across. Okay. Now, is any one part of this overly difficult? Like, you guys can put vectors tail to head. Okay? You guys can do v equals d over t calculations. You can do Pythagoras and trig. No one part of that question is tricky. It's putting them all together the right way that's tricky. And that's what we're trying to get you to do is you have the prerequisite skills, the Pythagoras, the tail to head, the trig, all of that. Can you use them as tools to solve a convoluted question? Okay, that's what both questions kind of are. Convoluted vector and v equals d over t questions. Right? The reason we do this is because the diploma exam is moving in a direction that says, make them read as much as possible, make them go all over the place with their thoughts, and then make them answer something. Okay? So we kind of have to expose you to that and go, hey, look, we need you to think kind of in, weird patterns and find your way through a maze to get to the cheese like a little mouse. Okay? Because that's in the end what they're going to want to do on a diploma exam. Okay? All right. So, yeah. All right. Let's have you write this one down. This is the other kind of vote question. So I'll show you both, then I'll have you try a couple. Okay, so like I said before, there's two kinds of vote questions. There's a rowing across question, like we just did, where you row across but don't go across. You end up downstream. This is a going across question. In order to go across, you must row at an angle slightly upstream so that the current will push you back to straight across. Okay, you got to kind of account for it. Or you got to, let's say you're like doing archery on a windy day and the wind is blowing directly across your shot. Okay, you don't aim for the bullseye. You aim a little into the wind from the bullseye, so the wind will blow the arrow back to straight. Okay, same idea here. So what we have in this question is we still know the distance across the river. It tells us that the river is 50 meters wide. So I'm just going to draw my river. Okay, and know that it is 50 meters across. Okay? Now, the river flows at 1.8 meters per second east. All right, so that's the current. I'm just going to draw that on here. Like so. Okay? The person rowing the boat can row at 2.5 meters per second. Okay? But what I don't know, I know how long to draw that arrow. I don't know which direction to draw that arrow. But here's what I do know. I do know that that arrow and this arrow will have a resultant, sorry, I'll use a different color, will have a resultant that points straight across the river. This is going to be my average velocity. Okay? So the trick with one of these questions is if you see that it's saying the person will end up straight across, okay, or is going straight across, okay, then you know the resultant points straight across the river. Okay, our average velocity points straight across the river. So now I know that the person has to row this way because the speed that they can row at and the current have to add up to this. Okay, I'm still doing tail to head, but I don't know where to point the first arrow until I draw what the arrows add up to and the one arrow that I know. Okay, we still know that that arrow here connects beginning and end. Okay, so I use it to figure out where the first arrow, the rowing arrow, would point. Okay, so I know how long that arrow is because the question says the person can row at 2.5 meters per second. That's great. Do you think the boat ends up going 2.5 meters per second? No. If you row into the current, that's hard work. The current's going to slow you down a little bit. Okay? So while you might be able to do this, you don't end up doing that. You end up going a little bit slower straight across. Okay? It doesn't mean you're any less powerful. You're still doing this. Okay? You're still rowing as fast as you can. But because you're rowing into the current, it steals a little bit of that. And you end up going a little slower, but you also end up going straight across. Okay, so the question wants to know, what's their heading? Okay, heading is another word for direction. Which way are you heading the boat? Which way are you pointing the boat? Okay, well that would be then this angle right here. I think I have enough information to find that angle. But it's a little different this time. I know the hypotenuse and the opposite side. Okay, so I'm going to use a different trig function here. Okay, to find theta, I'm going to go sine to the minus 1 of 1.8 divided by 2.5. Okay, so 46 degrees, and this will be west of north. Okay, they did tell me the current was going due east, that's how I know that's west of north. Okay. The second part of that question wants to know how long it will take to cross. So I'm looking for time. To get time, what two things do I usually need?
Like displacement and velocity.
Right? I need to know D and V. Well, I know D, it's 50 meters across. What do I not know right now? I don't know V. Is it on my diagram though? Right? V is on my diagram. The V that points in the direction the 50 meters points. Agreed? And I need those two. I can't use this one. This doesn't point across the river. This one points across the river. Can I get that one? Okay, that's the convoluted part, right? That's the, okay, I know how to do V equals D over T. I know how to put vectors together. Can I put those things together in a way that gets me to the solution of this question? Right? So, if I want to solve for V, I got a couple ways to do it. I could do Pythagoras where I go c squared minus a squared equals b squared. I could do that. Or I could just say, I know I know these two sides. Well, actually, no, that's the only way to do it because I don't have the angle. No, I do have the angle. Sorry, just calculate it. So I could do trig, and I could get this side as well. They'll all come out to the same answer. Okay. So I'm just going to do trig because I got the hypotenuse and the angle, so I'm going to find the adjacent side there. So green V is going to be so I'm looking for the adjacent side, and I have the hypotenuse and the angle. So times the cos of theta, so that'll be 2.5 times the cos of 46. Okay, so that side's 1.7. I didn't do the scale very well, did I? All right, so now I know that I go across the river at 1.7 meters per second. I know the river's 50 meters wide. Can I figure out how long it takes me to get across now? Okay, 50 divided by 1.7. But I'll use all the decimals because that's what I've done all this work for. Okay, so 28 seconds. I think we only have 2 significant digits, so 29 seconds. To get across. Okay, so a little bit different, okay, than what we've been doing. It's perpendicular vectors. The vector part of it is actually quite a bit easier than what you've been doing, okay, but it just combines it with something else. Okay? And that's what gets trickier and trickier in any unit in this course. Okay? We teach you the fundamentals and then we say, okay, play the game. Okay? Put all those fundamentals together and play the game. Right? And that's, I mean, it's like how anything works. Okay, try that one. It's a boat question, but it's a sky boat. Okay? An airplane flying in a crosswind is the same as a boat being rowed perpendicularly across the river. Okay, is this one quite a bit easier than the ones we did? It's only got the first part, right? Just putting the two vectors together and calculating the resultant velocity. Point of this question is to show you, it doesn't matter whether it's displacement, velocity, acceleration, force, or any other vector quantity, okay? We still draw them tail to head. So we got the speed of the plane, 225 kilometers per hour north, okay? And then we have the wind velocity, 112 meters east. Kilometers per hour. Okay, east, and then that means that if the plane does not correct for the wind, that the plane will go this direction. Okay, which, I mean, that's something if you were a pilot, you have to consider. Okay, if you are flying into a crosswind, you either have to aim into it a little bit to wind up going straight, or account for it in that you're going to be over somewhere else when you are done flying for a certain amount of time. Okay, it's a really big deal on landings. I don't know if you guys saw, like a couple weeks ago, they had all those like typhoon winds in Japan, and all these planes had to abort their landings because just as they were coming into the runway, gusts of wind would come up and it would turn, it would like shift the plane off and it would almost miss the runway, and they would have to like pull up and come in again. Okay, I don't know if you've ever been on a plane when it lands in a crosswind, but you can feel it. Okay, because you can feel the plane coming down, hitting and when the wheels hit the runway, the nose of the plane juts over really quick because that part's not on the runway being held in place yet. Okay, so the back goes, it'll kind of skid a little bit, and you can really feel it when it happens. Okay, it's quite dangerous. It's very tricky to land in a crosswind because you have to, your runway goes like this, but you have to aim the plane like that. Okay, so the plane is coming in at an angle, and then when it hits the runway, you've got to straighten right away so that the plane doesn't like flip over. If you weren't afraid of flying, Maybe you're a little more afraid of it now. Pilots are very skilled people, okay? Like being able to land a big jumbo jet in a crosswind that takes a lot of skill, okay? Now imagine trying to land a plane on an aircraft carrier with a crosswind while the boat's moving, okay? That's a whole other thing entirely, okay? So yeah, you get a little more appreciation for the skill of the people doing those things. Okay. All right, so to find this result in here, we just do Pythagorean theorem. So 225 squared plus 112 squared, and we'll get that it's 251 kilometers per hour. Okay, and it'll be at 26.5 degrees east of north. So just simple perpendicular vectors. Okay, the only thing that comes in with a regular boat question is after the fact, you'll have to do some V equals D over T stuff. Figure out how long it takes to go across, how far downstream you'll end up. Okay, so like a part B to this question could be that if the plane flew for 30 minutes, how far east of its original position will it be? Okay, or something like that.
Is this going to be on the question?
I don't think I put a boat question on the quiz, but I will double check before class is over. What's the point? There's 8 that I wanted. There we go. Okay, I want you guys to try number 8. Regular boat question. All right, so on this one here, okay, we've got the river, okay, so we'll draw the river on here, right, and we know that the boat can go 4 meters per second and it's heading directly north across the river. Okay, so there's the boat and its speed, 4.0 meters per second, okay, and we know the river is 125 meters wide. Okay. The current of the river is 2.1 meters per second east. Okay, those are the two vectors I was given. They're perpendicular. Okay, while they're happening at the same time, I still draw them tail to head. Okay, so what's the velocity of the boat with respect to the shore? Now, here's something we haven't dealt with. Up until this question, you could give me either angle and you'd be okay. This one is asking for a specific angle measured from the shore. Okay, that may not be the one you calculated. Okay, because most of us will draw this triangle here and we'll calculate that angle. Is that angle measured from the shore? I don't see that angle touching either shore. Do you? Okay. If I measure an angle from the shore, this is a shore, and this is a shore. That means the angle must touch the shore. Right? It's like saying, if I said, give me the vector relative due east, then you would have to give me north of east, not east of north. That's relative to due north. So this one's saying, give me a specific angle. Okay, now you haven't encountered one like that up until now. And it's okay if you calculated this angle because we haven't done one like that up until now. But now you know. Okay, so let's calculate the velocity of the boat. We need that side. What do I do to get that? Pythagorean theorem. Okay, so I go 2.1 squared plus 4 squared. Okay, so we get V. Okay, 2.1 squared plus 4 squared. Okay, it's going to give me 4.5 meters per second. And then I want to I'll find this angle, but then I'll go 90 minus it to get the one that's relative to the shore. Okay, because this is the one I want. Now, actually, this question did it wrong. Okay, it gave you that angle, right? That's the one you guys all calculated. It was inside the triangle. That's the wrong angle. Okay, that's east of north. That's not relative to the shore. Okay. All right, so if we calculate that angle, we're going to go inverse tan of 2.1 over 4. Okay, and if we do that, we get 28 degrees east of north. but I'm going to take this angle here, which would be 62 degrees north of east, or from the shore would also be an acceptable vector. Okay. All right, now that I've got that, part B, how long does it take the boat to reach the opposite shore? Is anything I did in part A useful to me for part B? None. Okay? Everything I calculated goes this way. That's not across the river. Okay? None of that helps me for part B. If I want to find out how long it takes to cross the river, I can only use vectors that go the same direction. Across the river would be good, since that's what it asks about. Okay? So I can use 4 meters per second, that's across the river, and 125 meters, that's also directly across the river. Those two go together. Okay? You can't ask me to calculate something about north using something east. Okay? They're not going the same way. Okay? So, to calculate the time, I would simply go d over v. It's 125 meters across, and I'm going across at 4 meters per second. Okay, so if I do that, I should get 31 seconds to get across. Okay? Everybody with me there? Could you have done it a longer way? And I only ask that because I've seen people do this. I've seen people go, okay, I know the angle, and I know it's 125 meters across, so I'll calculate how long it is along that V. Okay? And they do a bunch of trig that's way, it's right, it's just way more work than you need to do. You already have the information you need. You could do that as well. All right, for part C, how far downstream is the boat? Well, I know it takes 31 seconds to go across, and I know that for 31 seconds I'll be moving at 2.1 meters per second downstream. Okay? E times V equals D. Okay? Just use V equals D over T, okay, to get that distance. Okay, so that'll be 2.1 times the 31 seconds, and that'll get me 66 meters downstream. Tomorrow's quiz does not have any boat questions on it. Okay? Tomorrow's quiz will have some basic V equals D over T stuff like we did the first day. Okay, so like Science 10 stuff. Right? It will have some perpendicular vectors. There's a question that's only gives you a vector and says find its x and y components. Okay, so it's like the very simple breakdown stuff. Okay, and then one question like we've been working on for the last few days where it's 2 vectors, tail to head. So, okay, that'll be tomorrow's quiz. That's 22 marks. Okay, so try the practice quizzes I put up there. Get on the board, give those a whirl. Okay, V equals D over T. Try a couple questions from the workbook on V equals D over T. Okay, you'll probably be set for tomorrow. Okay? All right, good work today, guys.